Okay, so this is problem number 20. So in problem 20, it's straightforward. So it's just basically asking that you have a battery in series with the resistor. And so you have a battery, and I put the battery on this side, and we have a resistor. Here's the positive side, negative side. We're told that the battery, right, has a voltage of 25 volts. So that's 25 volts. The resistor R1 has, I'm sorry, I don't usually put numbers in, so it's 25 volts. I don't want to use symbols. R is equal to 5 ohms, so this is 5. And so part A asked, what is the, find the current through the circuit, power loss in the battery, and the total amount of energy lost through the resistor in 15 seconds. Okay, so we know the current is using Ohm's law, so this is actually V over R, 1 in this case, so this is voltage is 25 over 5. And remember, actually I do calculations to 2 significant digits, but remember, we're not really testing you on significant digits. I'm testing your understanding of concepts. So you notice I'm never putting 5.0, but I'm putting all my answers to 2 significant digits. So I'm just not writing it in. So this is 5, so we're getting 5 amps is the final answer. So the current is 5 amps. So there's 5 amps of current flowing through the circuit. So remember, in real life, we know that the carriers of charge are electrons, which are actually going from the negative terminal of the battery to the positive terminal. But it is by convention that we always assume that these particles, right, are going from the positive side to the negative side. And unless we're using the proof for this, actually using as an example of using a cathode ray tube and watching electrons go through a grid to make sure that the direction of the particle carriers were actually electrons. But we didn't know this, and all of the electronics that we do, right, it always assumes that we have current flowing from the positive side to the negative side. That's called conventional current, right? So conventional current. And so this is the current going through that circuit. So what is the power going through the resistor? So we can do it a couple of ways, but the power going to the battery or the loss, the power is going to be, did I say power, right? Find the power lost through the resistor, or find the power that's being lost, generated by the battery. So it's voltage times current. Okay, so remember, we could use current is equal to V over R, and then say it's V squared over R, which I'm not going to. I'm just going to make sure that you understand it's voltage times current. So this is 5, the voltage is 25 volts are being dropped from this resistor, and times a current of 5 amps. In this case, we'll get 5 times, which is 125 watts. Standard units, right? So, but I'll be rounding it off to 130, 100, or actually say 1.3 times 10 squared watts. W. I don't want to use single letters because they might get confused with variables, okay? So it's just 1.3 times 10 squared. So the answer is the power. So this is the power, this is the energy per unit time. So the power is equal to the energy per unit time. And so you're asked, what's the total amount of energy lost to the resistor in 15 seconds? Okay, so the power is given as 1.3 times 10 squared watts in 15 seconds. So I'm going to solve for energy. So energy, remember energy in our standard natural units, right, which are the kilogram meter second, which is going to be in joules. So it's joules per second. So power is, so I'm going to solve for E. So E is equal to power times time. Power is 1.3 times 10 squared watts. And the time is 15 seconds, and whatever the answer is, it's going to be the answer in joules. I'm spelling these out because I don't want to use single letters because they'll get confused with variables. So I didn't want you to get confused. Okay, so whatever the answer is, I won't even bring up my calculator. Actually, maybe I will. Where is my calculator? Oh, here we go. Okay, so actually we can do this in our head, but really I don't really care. So I really don't want you to. I want you to actually start getting the habit of just saying it's 1950. So this is 1.95 times 10 3, so this is actually 2.0 times 10 to the 3 joules. And okay, so it's about 2,000 joules roughly.